Hi, everyone. Wow, it's a little bright. As Redbeard said, I'm Joonis. I work at DigitalOcean. I'm an engineering manager at DigitalOcean. I'm going to talk to you a little bit about what we're doing with Kubernetes at DigitalOcean. It's this sort of a journey that we started on about a year ago, a little over a year ago. We were in an interesting place at the time, and we had been sort of starting to reevaluate some of the decisions we made early on at the life of the company. So I just kind of wanted to share some of the lessons learned, some of the ideas. Hopefully, I realize I'm the last speaker before lunch, so I'll try to give you some time back so you can get earlier to lunch. But hopefully, what I hope to give or impart is some ideas around how you can do more with Kubernetes. I think Dan just did a fantastic job highlighting some of the ideas around Kubernetes, how you could plug it into your existing infrastructure, how you can build on top of it. Things that I think a lot of times I haven't seen talked about a lot in the community. I think those conversations are starting to happen. I think the community is starting to really embrace Kubernetes for all of its capabilities. But a lot of us are still early on. We're treating it as more of like you just give it a YAML file and make it do its thing. But there's a surprising amount of power there. So let's get to it. Figuring out how this clicker works or doesn't work. Oh, wait. There we go. OK. Sorry, that took a minute. So first, I just want to quickly, for any of you that don't know DigitalOcean, so we're a cloud hosting company based here in New York. This company started out in 2012, essentially. I joined the company in early 2013, so I've seen the transition go from, 5 people to now close to 300. We brand ourselves as the cloud for the developers. We are very focused on the user experience for our customers. We want to make sure that you're getting sort of this experience that you would expect from, as they were talking about earlier on the cloud native panel, you have these companies like Stripe and Twilio, and we like to think of ourselves in the same company where the user experience is paramount. There are some other providers that aren't as concerned with the user experience, and I think that's one of the areas where we really differentiate ourselves. But where we're getting to now is the point that we're looking to grow the offerings that we have and provide teams of developers and small growing businesses with more and more ways to grow and scale their business as their business is growing. With that in mind, I just kind of want to talk a little bit about where we started. So this journey started, like I said, we a little over a year ago, we started sort of reevaluating where we were. Myself and another engineer had been sort of going through a few different teams and feeling the pain that we had around getting applications out there, getting them deployed, updating them, providing a good experience for that. We took the time to really start thinking about these things and propose that we would put together a new team that was focused on sort of solving that problem. I put in a slide to sort of help illustrate the situation we were in. So in theory, rolling out a new application or creating an update should be easy because we're just running automation. We're using configuration management. We're using a lot of the sort of best practices, or so we thought. But in reality, a lot of what we're seeing across different teams, was that they would start writing the automation, and it would just be a thing where they would be spending days or possibly even weeks just tweaking things and improving things. And that was all time that wasn't focused on building what was our core business, providing a better user experience, providing a better, more seamless experience, shipping code to the cloud, right? So we came to the conclusion that we needed to do something to that. And so to kind of go into a little bit more of the pain points that we're feeling. So across different teams, we had this proliferation of different deployment tools. So depending on which team you were, you might have multiple deployment tools depending on the different services. Across the company, I think we had somewhere between 5 to 6 different tools to deploy software with. And a lot of these tools had different set of capabilities, so maybe they were custom tailored to the product or the service that was being deployed, but a lot of them were sort of the same tool just being used differently. And there wasn't a lot of consensus on like what were the best practices or anything like that. So the experience was very inconsistent, and so people moving from team to team would have to learn new tools every time, or possibly. Teams that were using configuration management as their deployment mechanism were experiencing this pain where it could take hours for your software to get rolled out. Our Chef, we were at the time, or are still using Chef as one of the tools that we use for configuration management, and our Chef runs were pretty long. It was quite unreliable as well because we were sort of using the same tool that we would use to orchestrate the underlying node itself. Any change that was introduced to the base code for the node could potentially also break your deployment. So there are unrelated changes to your service that could potentially break the deployment of your service, which is not a great situation to be in. The teams that were shipping a lot of new services, because we're in this phase where we're sort of evolving our original infrastructure or architecture to be more of a microservice oriented architecture, which I think is a pretty common theme here. In some cases, it might take as long to write the automation to deploy your code that it would take to write the actual code to deploy. And that's really a terrible place to be. Like, a lot of people were feeling frustrated and unhappy about that. And furthermore, teams, because we really believe in this sort of a total ownership model, which means that the teams that write their software will also run their software and operate it. That means that the teams had to, if they're not using configuration management for their deployment, they would still have to learn configuration management to configure the nodes that their software was running on. So they weren't really getting around that. They were still having to do that and kind of double up. And this wasn't an area where a lot of people felt like they were experts. There wasn't a lot of interest, to be honest, to become experts in this because they felt like it was the necessary evil just to get their software out the door. The other thing was around, so we're a company that's focused on servers, right? We provide services as a service. So a lot of the mindset was focused around servers, not the idea of services. So sort of the pets versus cattle idea. And so when a given server would go down, people would sort of take care of that. But really, that didn't really matter a lot of times. There would be the on-call rotations could be pretty bad sometimes. And so what really mattered was whether the server was available or not, and not whether a given server was up or down, frankly. But the primitives that we had that we're working with weren't really lending themselves very well to this idea of like not caring about the server. We're in this phase where we were seeing a lot of adoption around containers, a lot of adoption around Docker specifically, and there was this weird mismatch of how you were running the code on your laptop for development purposes, or again, staging or testing or production. Like, those all had a little bit different way of how it was done. So it wasn't necessarily clear immediately that the software that you had running on your laptop would work in production. Like, it was like, works on my laptop, seems fine, let's ship it. But there were no guarantees around whether that would actually be the case. And then finally, the sort of one of the things that was starting to become increasingly a pain point was sort of as one of the common themes that the CoreOS folks really talk to is sort of how would you manage upgrading software? Vulnerabilities come out all the time for various versions of X, Y, or Z software that you're running, whether it's a language or OpenSSL or something like that. And we were really not happy with the process we had in place for upgrading stuff. So dependency management was really complicated or really involved. Sometimes it could be could be almost impossible. I shouldn't say impossible. Very difficult to get updates out there. And then teams didn't really have a consistent baseline of how observability around the operations of how their software was running in production. So there weren't clear sort of you couldn't go to a known place to look at the observability for a given service and be like, oh, it seems like it's doing fine. Like every team had to craft their own set of dashboards and own set of queries and everything else to go back to and find their logs or their metrics or what have you. So there's a lot of this kind of discrepancy between services and between teams. Now, to kind of illustrate some of the scaling that we're also doing, this is a graph of sort of the Dropless, which is our main product, launch over time. And as you can see, there's this trend where it's kind of going up all the time, up and to the right, which is nice. But that means all of these services that were sometimes questionably productionized had to be scaled very quickly. And we didn't really have a way of just like turning the knob and saying like, yeah, let's get more of that. Like, it was a pretty involved process. So, on the business side, we knew that we had some wants and needs, and we really weren't able to cater to these very well with the technology platform. So, we wanted to experiment with new things, rolling out new things, experiments all the time. And sometimes that was easy, sometimes not. It was sort of inconsistent. The visibility that we had, so when we launch a new feature or a new product or, new feature, you wouldn't necessarily have all the right telemetry in place because that may not be something that the team had built up to that point. That's a pretty important thing. Then as I mentioned, we wanted to have or give teams the sort of the total ownership of their end-to-end pipeline, but that meant that teams really needed to understand the whole stack and everything from virtual machines up to the UI. And so there's a lot of tools that were involved in that whole stack. And finally, when we launched new features that got popular, especially as we're moving things over to like a microservice world, we needed to be able to scale those individual services behind the scenes seamlessly without anybody really noticing. So there are a lot of things there. So we really kind of sat down. We knew that there's a lot of development happening, obviously, in this landscape. There's Docker was happening. There's a whole bunch of different projects. And so we knew that we didn't want to start from scratch. We weren't out to reinvent our own orchestration system or scheduler or anything like that. So what we did is we decided to start surveying the landscape a little bit. And so we looked at, these are the 5 main projects that we looked at. There are others that you could look at as well, but we felt like we wanted to find something that was open source. And these were all sort of at the different levels of maturity at the time. Nomad, Aurora, Marathon, Docker Swarm, and obviously Kubernetes. And so we kind of were thinking about like what can we do to really figure out like what we should go with. And so what we decided is we came up with a sort of a criteria. We wanted it to be something that was API driven. We were comfortable using APIs ourselves internally, and that's what a lot of our services are. It's just API-driven services, and so we wanted to find something that could be driven by APIs for our automation purposes. One of the big things that was really important for us was how is the community around this project? What does the ecosystem look like? It's surprising that when you don't have time to solve all of your problems, it's surprising when you reach out to the community and there's other companies that are solving the very same problems. You can collaborate and actually find that you don't have to solve every problem. Ease of operability, we already had distributed systems to run, so we didn't want something that was even harder to run. So ease of operability was like one of the big things that we knew from some other systems that we've ran before that was a pretty big, important thing. Container support, that was something that we really wanted to double down on containers. We believe that they're a great way to run software locally, also in testing, but also production. right? And so we wanted something that would do containers as a first-class primitive. It was important for us that we weren't going to be regressing in the feature set that we had. Not that we had a ton of features, but the ones that we had that were working well for us, we didn't want to just throw those out with the new system. And finally, it had to be production grade. So it had to be mature enough, there had to be enough users running it in production that we could feel comfortable running this ourselves as well. And so we didn't want to be necessarily the first user running this at large scale in production. And so since we're at Tectonic Summit, Kubernetes is obviously the one thing that I'll talk about. And so Kubernetes, we felt, was stacked fairly well on the criteria that we had. It was built to be driven by APIs from the ground up. I think this is one of the perhaps least, I shouldn't say least, but one of the things that Kubernetes doesn't get enough credit for is like how easy it is to really drive through the APIs. There's a lot of power there. There's a lot of ways you can build on top of that. And I think we've seen some of the previous talks mention how they've been able to enhance the API or use the Kubernetes APIs to enhance and really tailor it to their specific use case. The community itself is obviously, it's just, I've never seen a community like this. It's just outstanding. The team behind Kubernetes, they are bringing 15 years of container experience from Google. So that's just, you can't beat that. You look at all the other projects that are out there, and the teams behind them, they're good, but they're nowhere near the same level at which Kubernetes is at. I'll say the operability one, when we were starting out, we couldn't quite figure out all the pieces immediately. It wasn't obvious what their interactions were, but it was written in Go, so we felt comfortable operating that, and so we're able to sort of work through that. And I mentioned that, they had 10, 15 years of running containers at Google, so that was a pretty big deal for us. The feature set, this is probably the thing that sold us the most out of the box on Kubernetes. We looked at the feature set and we're like, how have we even been able to operate software without all these things before? Like, Kubernetes far surpassed all of our expectations in terms of what is available for you out of the box. And then, there are plenty of users to talk to who are using it already in production. By the time we were looking at it, we had just hit 1.1. So there was quite a bit of community adoption around it, and there were quite a few companies that we could talk to learn about their experience. So, I think it's pretty obvious that we chose Kubernetes. There's a lot of good things going for it. I think the other, and looking back now, I think this was absolutely the right choice. I think there's no question about that. So for us, the thing that we really wanted to learn from was, rather than giving our engineering teams just a raw set of tools to work with and kind of figure out on their own, what we wanted to do is actually come up with something that was a little bit more smarter, a little bit more refined for them. Our experience sort of had told us that when you expect people to do this, take another set of tools that's not necessarily directly the set of tools that they use for writing their software, they may not be as interested in learning that set of tools and really embracing that. So we kind of wanted to do something, more, provide something more for our internal customers. But the situation really what we wanted to avoid was this where we would come in and provide people with yet another solution. We didn't want to add more standards, so to speak, or we didn't want to create the 7th or 8th deployment method and not actually have people take their existing applications and migrate. The goal of our team was to reduce the number of ways we could deploy software. Ideally, get to as close to 1 as possible, but we'll take any number of reducements over the number that we had, which is somewhere around 5 to 6. And so the way we started thinking about this once we had Kubernetes up and running, we're kind of kicking the tires, is what can we do to make this more approachable for people? We knew that we had an existing set of systems that we had to integrate this on top of. So we had logging pipelines, metrics pipelines, we had alerting systems in place, we had load balancers, we had all these things that were already in place and that were already being maintained by other teams. And so what we wanted to do is just start with a really small curated set of features of Kubernetes and sort of start using and building the foundation on top of that. We sort of set out for ourselves to kind of keep this tractable. We figured that we shouldn't just try to do everything. So we had databases, everyone has databases, things like that, but we realized that that wasn't the place for us to start. We really needed to figure out what was the 80% case that we can build something for that's going to help us move the company forward. And then once we get there, we can start reevaluating what else is something we can do. And so we had some guiding principles we put in place, and these have served us well. There's always tension about sort of have we given people enough or not enough, and we kind of go back and forth, but we fall back on these quite a bit. And so far, things have been working out pretty well. So, what we built, we call it internally called just DOCC. Stands for DigitalOcean Control Center, if you're wondering. But we've just started calling it DOCC internally because that was a mouthful. And so, what it does is it's just a tool for deploying stateless services that are containerized in a high availability, self-healing manner. And so we've sort of, for DOCC itself, Kubernetes has a manifest, you sling around a lot of YAML files. And so we took some inspiration from that, but we wanted to reduce the number of things that people have to care about. And so what we started thinking about is what are the things that people need to define at minimum to make their applications run? And what is the kind of information we need from them to be able to understand how to operate their application for them? And so we had some things like number of instances, ports to expose, configuration to pass in, and we've sort of gradually grown this set of features. So resource usage is something that we've added in just to kind of be able to operate the clusters better ourselves. And then, furthermore, we allow you to sort of tell us okay, my service exposes metrics on this port, on this path, and that allows our metrics collector to come in and just make those available to you on a dashboard. Sort of what kinds of things you care about. So the metrics we're collecting for you, what should we alert you on? That's another easy configurable in there. And then if your service is an external service, you just tell us what is the domain, what is the address at which you want to expose it to the outside world, and we make it happen. And finally, one of the things we did put in there is we really wanted to drive accountability. So we asked people to say, this is the team that owns this service. So there's a maintainer, basically, field. And you fill that in with a Teams alias, and that allows us to go back to Teams and say, hey, we've got this new feature. We notice your application isn't using it, or maybe your application is misbehaving, or it's under a huge load and maybe needs to be scaled up, things like that. But it allows us to communicate with teams without necessarily being at the blocker for them getting their stuff out the door. So we're not sort of bottlenecked, but we have a way to come back to the teams and talk to them about the services they've deployed, assuming everyone's a good citizen and actually defines this information, which people do. So just to kind of give you a quick example of how this works. So we have a manifest, and this is probably the most basic manifest that you could have. And so here you can see there's a name, there's the scale, and then the container to run and a maintainer. And that's all you would need to deploy an application onto Kubernetes, to have your application be deployed onto the Kubernetes. And so what our service then turns that into is a deployment object that points to a replica set and a bunch of pods. So our service itself just creates the deployment, and Kubernetes takes care of the rest underneath the hood. And so it's pretty simple. So to kind of evolve the application, let's say you wanted to expose your application to other services that are running inside of that cluster, all you would need to do is define this set of ports, and following that declaration, it would just evolve your deployment in a way that it would now be routable within the cluster, which is very simple. And then finally, let's say that I wanted to make this application available on the internet. All you would say define is this ingress ingress section, and in there you would say, serve HTTP, and when traffic comes into this address, send it over to my application on port 8080. And then finally, what that would do is it would create an ingress that points to the service that, again, points back to all those pods that you deployed. So it's very simple. And all you would need to do as a user is define, a couple of lines of JSON. So it's not like a lot of the Kubernetes primitives themselves. There's a lot of YAML you end up writing, and people tend to write a lot of templating around those and things like that. But we decided that rather than teaching everyone all the primitives within Kubernetes, we actually wanted to take a step back and abstract those things and sort of expose them selectively, and only sort of the parts that we felt like were useful. And so sort of architecture-wise, what it looks like is very actually similar to what the Conqueror guys wrote. So we have a little service client command line application called DOCC. You use that along with your JSON file to communicate with our DOCC server, which runs inside of Kubernetes. And then the DOCC server itself just communicates with the Kube API server and takes the JSON that you give it and turns that into the Kubernetes objects that make your software run inside the cluster. So, whether that be controllers or ingresses or other things, And so kind of reflecting back on our journey on the past 12 months. So the feedback I've gotten from people is that the service we built for them is one of the most pleasant experiences they've had deploying software. So I've never heard anybody say that they don't like the service. They usually tell me, well, I would like you to be able to do X or Y. And those are usually things that are on our roadmap or things that we're thinking about exposing. But the conversation is always like very positive, and it's very easy to get this kind of like collaborative mindset going, because we're both interested in making the service better to be able to better serve our users' needs. And so some numbers or some things that we've done, we have 50 applications running. I didn't mention this, but we have about 20 clusters across our 12 data centers running. So, these are numbers from some of our bigger clusters in some of our main data centers, I suppose. But, the idea was that you would be able to deploy the same way to all of the clusters that you have. So we have services that live only in a data center, or maybe they live in just, a couple of regions, and the way you deploy to them is always the same. We've reduced the time to deploy from, maybe days to hours to minutes. And then finally, we had a hackathon, 2-day hackathon recently, where we saw 154 deploys over the course of about 36 hours with 16 new applications running on this. And my theory is that we wouldn't have shipped as many things during that hackathon had we not had such an easy way to do that, and had people not had gotten so used to this way of deploying and managing their software. So I think it's going well. Lessons learned, Kubernetes moves really fast. I think this is one of those things where we just had 1.5 land yesterday. You just have to, if you're investing in Kubernetes, make sure you're a part of the community, make sure you're constantly talking to people and staying up to date, because there's a lot of problems have been solved that we had starting out over the past 3-4 releases, and that just keeps happening. So it's important that you stay up to date. Getting involved in the community, I think, likewise, is really good. Knowing people when you have problems, it's good to know who you should go to talk about those. Investing heavily in automation. Upgrading software is a real thing. Like Tectonic is fantastic. I really think that the self-driving idea is the way of the future. That's where we should all be going. And so I think that's something that you want to do up front, rather than by the time you have 50 clusters across, God knows how many data centers. Get some people that know what they're doing in early. We try to learn everything ourselves. I think we probably spent a couple of months just kind of bouncing around, kicking the tires. Whereas if we had brought in somebody like Kelsey, that he could have told us what to do from day one. And then, one of the things, a lot of people, Kubernetes is an API. So like, use the API. I think that's the one thing we've learned, and I think we'll continue to see learn is people, I think of it as a framework that you can build your own platform on top of. That's really something that I think we should start. I'm hoping that we'll see more of in 2017. And last but not least, you're in great company. This is a really great community, so make use of that. And then there's a couple of ideas for future that we're looking into. Service mesh using Linkerd. I'm a big fan of pushing logic to the network and letting that take care of it for you. You don't want to be reinventing those same client libraries in every single language that you use for client-side load balancing, timeouts, deadlines, things like that. Use something that lets you do that more easily. Network policies are a thing. Security is a big deal. I think it's great that there are primitives to be used for this. And then finally, one of the things I wish Kubernetes itself would do a little bit better job of is the secret management, but thankfully there's an open source project for that from HashiCorp that I think is going to be really hopefully getting more and more integrated with Kubernetes and made available as just a no-brainer solution. And finally, I'll leave you with this quote from someone that I worked with on the team. What we were really doing is reducing the developer decision fatigue so that they can make the decisions that really matter. So they don't have to worry about deployment anymore. They can now focus on building better applications. And finally, since I have the opportunity, I wanted to give a quick shout out to the team, some of whom are here today. They're a really fantastic group of people. I wouldn't be up here without them. And so the credit goes out to them, belongs to them entirely. They've done a really fantastic job. And I'm very happy to have had the opportunity to work with them on stuff like this. And that's it. Thank you very much.